The James Webb Space Telescope, humanity's most sophisticated tool for exploring the universe, has revealed yet another extraordinary discovery. The newly uncovered imagery of Pluto is reshaping every belief we once held about this icy planetary object, unveiling revelations both awe-inspiring and deeply thought-provoking. Previously dismissed as just a barren, frozen sphere at the edge of our solar system, Pluto now presents itself as significantly more intricate and lively, showing signs of concealed movement, tectonic changes, and complex chemical structures that challenge current understanding. These groundbreaking findings have left scientists in a state of amazement and confusion. At the heart of this renewed understanding lies Sputnik Planitia, the famous heart-shaped area on Pluto's surface. What was once assumed to be a solid sheet of nitrogen ice is now believed to conceal a vast subsurface ocean beneath its cold exterior. Surrounded by thick layers of ice, this enormous water reservoir could become one of the most pivotal breakthroughs in the search for extraterrestrial life. Protected from the harshness of space, scientists are now contemplating the possibility that microscopic organisms might exist in these hidden depths. Pluto's surface continuously astonishes researchers. Towering ice-covered mountains rise to elevations comparable to Earth's highest peaks, while vast, smooth plains remain pristine, suggesting that geological renewal occurred relatively recently. Such active phenomena were entirely unexpected for a world once thought to be geologically dormant. Heat generated from Pluto's core drives convection beneath its frozen shell, causing nitrogen ice to shift slowly, much like cooling lava in a lava lamp. These events depict a world far from desolate. Pluto is, as revealed in these released images, pulsating with energy. Despite its vast distance from the Sun, Pluto now joins an expanding list of frozen worlds and moons such as Europa and Enceladus that might harbor life beneath their outer ice layers. Water and organic materials could interact in ways that spark prebiotic chemistry. Even if more complex life forms are not present, the discovery of microbial life on Pluto would fundamentally alter our perception of habitability across the universe, proving that life can persist in environments once considered inhospitable. Pluto's relationship with its moon Charon is unique within our solar system. Nearly equal in size, the two bodies influence each other gravitationally, producing internal heat and triggering dynamic changes on both. Charon too hides its own mysteries. Deep valleys and a distinctive reddish hue suggest a shared origin with Pluto. Material from Pluto's surface may transfer to Charon, signaling a chemical exchange that could involve the necessary components for life. None of these remarkable discoveries would have been possible without the James Webb Space Telescope. Its infrared detection allowed astronomers to peer beneath Pluto's frozen crust, revealing details overlooked by previous missions. By examining Pluto's surface and atmospheric layers, Webb has identified organic molecules and thermal fluctuations, providing a picture of an unexpectedly active world. Pluto's atmosphere, although thin, is exceptionally complex, composed mainly of nitrogen with traces of methane and carbon dioxide. It forms a fragile haze stretching hundreds of miles above the planet. As Pluto moves along its elongated orbit, its faint atmosphere undergoes dramatic shifts. When closer to the Sun, surface ice sublimates into gas, forming a temporary shell. As Pluto moves farther, this shell refreezes onto the surface, creating a cyclical pattern unlike anything else in the solar system. These atmospheric cycles offer rare insights into planetary adaptation to extreme conditions. One of the most striking features on both Pluto and Charon is the reddish streaks on their surfaces. These areas are thought to be coated with tholins, complex organic compounds formed when ultraviolet radiation interacts with methane in the atmosphere. Tholins not only give the surface its color, but also hint at the emergence of pre-life chemistry, a fundamental chemical pathway that could form the foundation for biological evolution. Scientists are particularly intrigued by how these compounds might interact with subsurface water ice. Could these tholins serve as primitive life precursor units carried into the hidden ocean to merge with other organic molecules? This fascinating question is one that researchers are eager to explore. Among the most transformative revelations about Pluto is the likely presence of a vast ocean beneath its icy surface. This ocean, maintained in liquid form by geothermal Heat from radioactive decay in Pluto's core could occupy much of the planet's interior. On Earth, environments such as deep-sea hydrothermal vents are teeming with life. If Pluto's secret ocean provides similar conditions, it might support microbial ecosystems, or perhaps even more complex life forms. Uncovering Pluto's hidden depths could dramatically shift our perspective on where life might thrive, showing that even the most unlikely places can harbor life. The release of declassified images and data from the James Webb Telescope has generated tremendous excitement and speculation. Governments, academic institutions, and the general public are all fascinated by what Pluto's depths may reveal about the broader cosmos. For many years, Pluto was dismissed as an insignificant world. Yet, these new discoveries highlight how little we truly understand about our cosmic neighbors. With each new set of data released, expectations rise concerning numerous unresolved questions. The achievements brought about by the Webb telescope mark only the beginning. Future plans include orbiters and landers intended to explore Pluto more deeply. These missions could confirm the existence of the subsurface ocean and provide the first direct evidence of life beyond Earth. Some have even proposed sending robotic submersibles into Pluto's hidden sea, a monumental engineering feat that would stand as one of humanity's greatest achievements in space exploration. As technology advances, the dream of directly exploring Pluto's depths becomes more attainable. This endeavor could drastically alter our understanding of the universe in ways we can hardly imagine. One of Pluto's deepest mysteries is how it maintains geological activity despite its great distance from the Sun. Pluto generates enough internal heat to drive convection in its icy mantle and support a hidden ocean. This heat likely originates from radioactive decay in its core, which releases energy over time combined with tidal forces from Charon. This internal heat may explain Pluto's unexpected geological vitality and enduring subsurface sea. Although Pluto lacks a strong magnetic field like Earth's, it still interacts with the solar wind in unique ways. These interactions erode parts of its atmosphere, creating a stream of charged particles that drift into space. The JWST has detected unusual magnetic and energetic phenomena around Pluto, suggesting interactions between its magnetic environment and the Kuiper Belt. These findings offer a rare glimpse into how small bodies and dwarf planets interact with their stellar surroundings. The revelations about Pluto are just the beginning. With missions aimed at the Kuiper Belt and beyond, humanity is poised to explore the farthest reaches of our planetary system. Pluto has opened up new pathways, proving that even the most distant worlds have stories waiting to be discovered. As technology matures, the line between science fiction and reality continues to blur. From autonomous submersibles diving beneath frozen seas to missions reaching the Kuiper Belt, Pluto reminds us that the universe is vast, mysterious, and full of awe-inspiring wonders. Once thought to be a frozen, lifeless speck, Pluto has proven to be anything but ordinary. Its dynamic geology, enigmatic atmosphere, hidden oceans, and organic compounds challenge all previous assumptions about the outer solar system. The James Webb Telescope's stunning images and groundbreaking findings have transformed Pluto from an obscure anomaly into a central focus of scientific inquiry. These revelations remind us that mysteries remain even in the farthest reaches of our solar system. Looking ahead, Pluto symbolizes hope and curiosity. Its secrets continue to inspire new missions, pioneering innovations, and fresh questions about our place in the universe. Could Pluto harbor life? What other wonders might be hidden beneath its icy surface? What can it teach us about our origins? Pluto's story is far from finished. With every new discovery, we are reminded of the vastness of the universe, its hidden depths, and the endless surprises it holds, as long as we are willing to pursue them. What are your thoughts on the James Webb Telescope's findings about Pluto? Do you think it could sustain life or hold profound mysteries that we are not yet prepared to uncover? Share your thoughts below, and don't forget to subscribe for more fascinating tales from the cosmos. The journey to unlock Pluto's secrets has only just begun. With each revelation, humanity's understanding of the planetary realm expands. The James Webb Telescope has opened the door to a world we once believed we understood, only to discover that Pluto is a complex, dynamic planet filled with mysteries we are only beginning to unravel. These discoveries shift our understanding of Pluto and challenge our beliefs about life beyond Earth. As we continue exploring Pluto's surface, atmosphere, and hidden realms, upcoming missions will address some of the most important questions regarding its potential to support life. Could the ocean beneath its icy crust harbor microorganisms or even more complex ecosystems? Could Pluto's unique atmospheric cycles teach us about the evolution of distant exoplanets? This ongoing scientific exploration is essential for answering these and many more questions with the power to transform how we think about life on other worlds. In collaboration with the JWST, additional scientific instruments and exploration missions will deepen our knowledge of Pluto. Orbital spacecraft will provide new perspectives while landers and potential rovers may gather surface samples. Future missions may directly confirm the existence of the subsurface ocean, proving that life can survive in the most unlikely environments. As technology advances, we might even witness the launch of robotic submersibles beneath Pluto's icy shell, a monumental achievement in space exploration that would allow humanity to explore one of the most distant, mysterious worlds with unprecedented precision. Pluto's strange and unpredictable behavior continues to challenge scientists. Despite its remoteness, it generates internal heat that drives geological and atmospheric processes. This warmth created by radioactive decay in its core helps explain the migration of ice on its surface and the potential existence of a subsurface ocean. The gravitational relationship between Pluto and Charon also contributes to this internal thermal budget. Tidal flexing helps maintain geological activity. This intense examination of Pluto's geology and atmosphere is redefining our understanding of planetary development in the cold reaches of space. The fact that Pluto remains so active under such extreme conditions challenges prevailing assumptions, suggesting that our understanding of what is possible beyond Earth is still far from complete. Fueled by the JWST's groundbreaking discoveries, the ongoing search for life on distant planets is shaping the future of space exploration. Whether it's microbial life on Pluto, hidden oceans on other moons, or habitable environments far beyond our solar system, the quest to define the conditions necessary for life across the universe is only beginning. As we push our boundaries and explore new celestial territories, Pluto remains at the heart of scientific curiosity and deliberate exploration. In conclusion, the revelations provided by the James Webb Space Telescope are just the start of humanity's journey to comprehend the cosmos. Pluto, once regarded as a cold, lifeless outpost, is now recognized as a vibrant, dynamic world filled with unexpected qualities. As investigations continue into its surface, atmosphere, and secret waters, Pluto may hold the answers to some of the most profound questions in science, yet its mysteries are far from fully understood. As we continue to explore and uncover Pluto's enigmatic terrain, atmosphere, and hidden oceans, future missions aim to tackle crucial questions regarding its capacity to sustain life. Could the ocean beneath its icy shell harbor microbial life, or even more complex ecosystems? Could Pluto's peculiar atmospheric rhythms provide clues about the evolution of distant exoplanets? This ongoing scientific journey is vital for answering these and countless other questions with the potential to reshape how we envision habitability on other worlds. Alongside the JWST's mission, other scientific instruments and exploratory endeavors will expand our knowledge of Pluto. Orbital spacecraft will offer fresh perspectives. While landers and potential rovers may collect surface samples, later missions may directly confirm the existence of Pluto's subsurface ocean, demonstrating that life can exist in the most improbable conditions. As technology continues to evolve, we may even witness the deployment of robotic submersibles beneath Pluto's frozen shell, a monumental milestone in space exploration that would allow humanity to study one of the most remote, mysterious worlds with unprecedented precision. Pluto's strange and unpredictable behavior continues to puzzle scientists. Despite its remoteness, it generates internal heat that drives geological and atmospheric processes. This warmth, sourced from radioactive decay in its core, helps explain the migration of ice on its surface and the potential subsurface ocean. The gravitational relationship between Pluto and Charon further contributes to this internal thermal process, with tidal forces helping to sustain geological activity. This in-depth analysis of Pluto's geology and atmosphere is reshaping our understanding of planetary evolution in the farthest regions of space. The fact that Pluto remains so active under harsh conditions defies previous assumptions, signaling that our comprehension of what is possible beyond Earth still remains incomplete. 8.